Hi, this is Ashutosh and welcome once again in this course of indefinite integrals. We are in lesson number 10 and in this lesson we are going to do the substitution method in a particular kind of integrand in where the tanx and secx are in the product form and there are powers on them. So let us try to understand how the integrand will look like and how we can apply the guidelines we have. So suppose I have the integrand form tan to the power mx times sec to the power nx, where m and n are natural number, of course. So if the power of tan x is odd and we don't have to see the power of sec x, whatever be the power of sec x, we have to check for the power of tan x only, and if it is odd then we have to save a factor of sec x tan x. Means one factor we should take from tan and one factor from we have to take from sec, and save this sec x tan x and attach with tx, and express the remaining factors in terms of sec x, and then substitute t is equal to sec x. And the second guideline is what if the power of sec x is even. So this time we don't have to see the power of tan x, we have to save one factor of secant square x and express the remaining factors in terms of tan x, and this time we have to substitute t is equal to tan x. So you can easily guess then what happens when the tan x has the power odd and sec x has the power even. It is the matter of our choice. We can apply any of these guideline. Now the third case is if in other cases the integrand is simple, or we have to apply trigonometric identities or integration by parts. So there are three things. If any of these two cases will not happen, then we have to simply use our trigonometric identities or trigonometric transformation, we can say, or integration by parts. Let us try to apply this in this example. So in this example we have tan cube x sec to the power 5x as the integrand. So of course we can see that the tan has the power odd and we are not going to see the power of sec. So this time we have we have to save the factor of sec x tan x. So what we can do, we can take one factor of sec x from here and one factor of tan x from here, and we can multiply them to attach with dx. Now the remaining terms will be now tan square x sec to the power 4x. So we have to transform the remaining terms in the form of sec x, and for this sec to the power 4x is already there. So we have to simply transform this tan square x into the form of sec square x. So we can write this tan square x using the identity, and we can write sec square x minus 1, and from there we can easily guess that the sec x has the derivative sec x tan x, so we can simply substitute t is equal to sec x, and of course we get dt is sec x tan x dx, and from there we can simply see the integrand as t square minus t times t to the power 4, and of course after multiplying it we will get t to the power 6 minus t to the power 4, and after integrating we will get t to the power 7 minus t to the power 5 by 5 plus c, and substituting back the value of t, that was sec x, and we get this as the final answer. Now the second example is tan square x sec to the power 4x. So we can see that the tan has no odd power, so we are not going to see the tan, we are going to see the sec. So this time sec has even power. It means we have to save one factor of sec square x from that. So I have taken one sec square x from here, so we are left with sec square x from the sec to the power 4x and tan square x as it is. But this time we have to transform the remaining factors in the form of tan. So this tan square x should be as it is, and the sec square x can be transformed by using the identity as 1 plus tan square x. So now we are in the situation to simply substitute tan x as t. So of course t is tan x and dt is sec square x dx. So we will get the integrand in form of t as t square 1 plus t square dt, and of course after multiplying it we'll get t square plus t to the power 4, and integrating we will get t to the power 3 plus t to the power 5 by 5 plus c, and t was actually originally tan x, so we'll substitute it back. Now what happens in this example? Let us see. The tan has the power 3 and the sec has the power 4, so they are actually double benefit. We can see here that the tan has also the power odd and sec has also the power even, so it is our matter of choice. So actually it is very easy to see that if we are free to choose any of them, it is easy to see that sec square x can be attached with dx easily, and we are left with sec square x and tan cube x, and again this sec square x can be transformed in the form of tan x, and after that we have to substitute t is equal to tan x, and dt sec square x will be here, and so t cube t cube times 1 plus t square dt will be there as the integrand, and so this integration can be done easily and substituted back the value of t, that was tan x, and that is answer. What happens in such situation if we can see that tan to the power 5x dx? So we can see here there is no secx present, but still we can do something here, and what we can do, let us try to understand. This tan to the power 5x can be written as tan cube x times tan square x, and this tan square x can be written as sec square x minus 1. So this sec square minus 1 can be used to get multiplied with tan cube x 1 by 1. So we will have two integrands. The first one is tan cube x sec square x, and the second one is tan cube x dx. So we can see that the first integrand is now in our required form, where this tan has the power odd and sec has the power even, and of course we can simply see that the tan has derivative sec square x, so why not we can substitute this tan x as t. So let us try to evaluate this first integrand, that is I1, and here we can see that tan cube x sec square x dx is there, so t is equal to tan x and dt sec square x. And of course after integrating we will get tan to the power cube by 4 plus c. Tan to the power 4 by 4. Alright, so this will be tan to the power 4 by 4 plus c1. And for the second integrand we have tan cube x, and for this again we have to write tan x into tan square x, and for this tan square x we can again write sec square x minus 1. And after just separating these two terms in the two integrand, we will have tan x into sec square x as the first integration and tan x as the second. So we will have again this tan x into sec square x, and in order to evaluate this integration we can simply use the substitution process. To substitute t is equal to tan x, we will get the derivative sec square x. So if I substitute this is t, so this will be dt, and so the integration will be t square by 2, and so we can write tan square x by 2, and the integration of tan x is log sec x. So after just seeing this is I1 and this is I2, and we have to write I as I1 minus I2, so we can write this as the answer. So you can see easily, you can observe that whenever the tan has the power, we have to just reduce that power and take the factor of tan square x in each step. Means after, suppose this is the first step where tan to the power 5x was given, so I have taken first time the tan square x as the factor. After evaluating integration we again get tan cube x, and again I am taking one factor of tan square x here. So if the power is more than 5, we can treat the similar process there also. Now if the power of tan is odd, if the power is of tan x was odd, what we could do, we have seen here. But what happens if the power of tan is even, but we don't have sec x here? So this time again we have to do the similar process, that I have taken this tan square x as a factor and attach to this with tx, but this tan square x can be transformed to sec square x minus 1, and again I can have two different integrals. So this tan square x sec square x and this tan the integration of tan square x sec square x can be done by the substitution, and so we will have tan cube x by 3. Because when you substitute t is equal to tan x, the derivative is sec square x dx, so this is t and this whole will be dt, and so this t square by 2, sorry, t cube by 3, and so that is the integral. And now for the second part, this is tan square x, we can again write sec square x minus 1 and do the process. So suppose I have tan to the power 6x, we can do the similar process. So whatever the power is odd or even, we have to just take one factor tan square x, transform this into sec square x minus 1 and move ahead. And this is the one of the case where the powers are opposite, means tan has the power even and the sec has the power odd. So what will happen? So for such cases, let us try to transform this tan square x into sec square x minus 1 and let us see what will happen. So now we will have sec to the power 5x minus sec cube x, and here sec to the power 5x and minus sec cube x can be understood as two different integrands, and this can be done by the help of integration by parts. We cannot do by the simple substitution or transformation. So whenever we have the power of sec as odd, we have to deal with such situation by using integration by parts. We cannot do the substitution process. So we have understood all the things that when the power of tan is odd or even and sec x is not present, we can simply take one factor of tan square x and go further by substituting this tan square x as sec square minus 1. And if in other cases where the tan is and sec are both present and tan has odd, sec has even power, we have to just follow the guidelines. So this is the last two examples of tan, the tan to the power 4x and tan to the power 5x we have done here. They are actually the other cases of this guideline, in which we have simply written or simply understood that in other cases we have to simply apply the trigonometric identities or integration by parts. So we are not using the integration by parts until you get sec to the power odd number. So that is the whole integration process or the substitution method, where the tan and sec has some powers of the odd even combination as the integrand, and also where sec is not present and tan is not present in such cases. So that's all for today. Thanks for watching.